Okay, let's do 7.2 part 3. Okay, so we're going to take a little different look this time. We're going to look on the number line. We've been looking at area. So we've been looking at the p-value, which is area for the data, and we've been looking at alpha, which is the area for the significance that we want to be looking at. So this time we're going to look on the number line, and they ask for critical value. Remember, critical value means that we're looking for a z-score, and we want to look at a rejection region. They told me they want a left-tailed test. Okay, so that means we're going to be down in this end, right? We're looking at a left-tailed test. And we want this area to be 0.01. Well, we know how to do that. What we're going to do is put it into StatCrunch, into the normal calculator. And when we put it into StatCrunch, we have to make sure we put our arrow in the correct direction. We're going left, so we're going to have a less than or equal to, and then we're going to put the area in. Remember, the area is always on the right-hand side. The z-score is inside the parentheses. The area is on the right-hand side. And so we're going to put the area of 0.01 in on the right. And when we do that, we get a z-score of negative 2.33, which totally makes sense because we know we want to be down in this area. And so the negative 2.33 is sitting right there. This is our rejection area. So our rejection area is going to be anything less than or to the left of negative 2.33. And so at this point, if they gave me a different z-score, let's say they gave me a z-score of negative 3, well, negative 3 is to the left, and so I would reject. But if they give me a z-score of 1, then I'm on the right-hand side of the rejection region, and so I would fail to reject. But we'll look at some problems like that. Okay, so again, they're asking me for critical values and a rejection region, but this time they tell me it's a two-tailed test. So I do have to be careful because I know that it is a two-tailed test. I have to do my area a little bit different. My significance level is 0.05. It's 5%, but I have to split that up into two areas, and therefore I need to divide it by 2. And so this side would be 0.025, and this side would also be 0.025. So I only have to do this if it's a two-tailed test. I have to take my area, my alpha, and split it up into the two sides. But I know by symmetry I'm going to be okay. What I'm going to do is go to calculator normal. Let's do the left side first. So I would do the left side and put my area of 0.025 in. When I do that, I'm going to get negative 1.96. That looks familiar. And then on the other side, I'm going to go to the right, still put my area of 0.025, and this time I'm going to get a z-score of 1.96. Okay, so those are my two critical values. What's going to happen with a two-tailed test is that these ends are my rejection regions. And so if I am less than negative 1.96, I'm going to reject. If I'm greater than 1.96, I'm going to reject. So these are my rejection regions. In the middle is going to be my do not reject region. Okay, so this chart is just showing me where I'm going to reject, where I'm going to fail to reject. And so if I have a one-tailed to the left here, the shaded in area or the region to the left is going to be my reject. The other area to the right is going to be fail to reject. Okay, it's going to work the same way for the one-tailed test that goes to the right. My rejection region is going to be the region on the right. My fail to reject is going to be the big region on the left. Okay, and then with my two-tailed test, what ends up happening is I end up with two rejection regions, right? Each of my shaded areas I'm going to reject. And so those are both rejection regions. And then this area in the middle is going to be the fail to reject. Okay, and then of course it gives us a little note on the bottom that says, remember, failing to reject the null hypothesis does not mean you have accepted that it's true. That's very important. All right, let's try a problem. So employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors, which is 88,200. Okay, so the claim is that the mean salary is less than 88,200. Therefore, that's going to be my alternative because it's a less than. It's not less than or equal to. And that leaves me then with the null hypothesis being the complement, and that will be greater than or equal to. Okay, we also know that our tail is going to point to the left because our alternative inequality is pointing to the left. So I drew that here. And then we're going to gather everything we need. So the sample size is 20. That's small, but the problem does say it's normally distributed. We have our sample mean of 85,900. We have a population standard deviation of 9,500. That means we're going to be able to use z-stat because we have sigma. And then finally, we have an alpha or a significance level of 5%, 0.05. Okay, so now we can get to work. We have everything that we need. Okay, so this is if you're going to do it by hand and not use StatCrunch. I recommend StatCrunch. But if you're going to do it by hand, you're going to have to find the z-score, and you have to remember that you have to adjust the standard deviation by dividing by the square root of n. StatCrunch is going to take care of that for us. Okay, so this is still the problem. If you're going to do it by hand, you're going to be comparing a z-statistic or your critical value of negative 1.645 versus the z that you found by hand. But let's go to StatCrunch and see what that looks like. Okay, so if you use StatCrunch, they gave us the population standard deviation sigma. So we are good to go. We know that we can use z-stat. That will change in the next section. We're going to put in everything we know: sample mean, population standard deviation, sample size. We're going for a hypothesis test. We're looking at 88,200, and we want our alternative to be less than because we want to go to the left. Okay, so as soon as you hit compute, StatCrunch gives you everything you need. It gives you the p-value if you want to look at it that way. It gives you the z-stat if the statistical z-score that we need, which if you found by hand, you saw in that other chart that it was negative 1.08. And so we now have everything we need to figure out whether we're going to reject or whether we're going to fail to reject. So if we do it by the p-value, which we did earlier, the p-value is 0.1395, which is definitely greater than our alpha, right? And since it's greater, we are going to fail to reject, okay? And so we know by the p-value that we're going to fail to reject. Now, if we do it the way they want us to for this problem, let's take a look. We have a left tail out here. And if we check our normal calculator, if we have okay, so if we used our normal calculator to find the z-score for our alpha, we would get negative 1.645 here. Okay, and so that is our rejection region. Anything less than negative 1.645, we're going to reject. Well, if you notice, our z statistic is negative 1.08. Well, that's way over here, right? That's right here. And so that point right there is negative 1.08. That is not inside our rejection region, and so we're going to fail to reject. So it's just two different ways of really looking at the same thing. The p-value is really easier, I think. With the p-value, if p is greater than alpha, we're going to fail to reject. If it's less than alpha, we're going to reject. Or you can look on the number line here. Our rejection region was to the left of negative 1.645, but we're sitting to the right. And so also we're going to fail to reject. Now, because our claim was the alternative, we do not have enough evidence to support our claim. We would have had to reject the null hypothesis. So we cannot support our claim, and we're going to stick with the null hypothesis for now. All right, let's look at one more together, and then I'll let you guys get started in the homework. So a researcher claims that the mean annual cost of raising a child is $14,050. That's an equal sign, and so that is going to be our null hypothesis is equal 14,050, and that's our claim. Therefore, our alternative is going to be not equal to, and by it being not equal to, we're going to have a two-tailed test. Okay, then we have everything else we need. We have our sample size, we have our sample mean, we have our population standard deviation, and finally we have alpha. Now, by having an alpha and a two-tailed test, remember we have to split up this 10%. And so we're going to have 0.05 on this side. And 0.05 on this side. And that's because we have to split alpha up into two tails. Okay, this is just showing if you want to do it by hand, how you would find the z-score. Again, don't forget to adjust the standard deviation by dividing by the square root of n. We're going to move on to StatCrunch. This is also, if you're doing it by hand, you would go in and find the z-score for the 0.05, which is 1.645. Therefore, we're going to have the positive and the negative for our rejection regions, and you compare that to your z-score that you found on the previous page. But let's go look at what StatCrunch looks like. All right, I went to ZStat, and that's because I know my population standard deviation. I went in and put all my information in. I put my 14,050, which was the claim, and I put not equal to here. Now, StatCrunch is going to take care of everything for me. And so when I hit compute, it gives me a p-value of 0.0473. When I compare that to alpha, alpha is 0.10, it's 10%. So my p-value is definitely less than my alpha, and I'm going to reject. But this problem wants me to look at the t-stat. So, or excuse me, the z-stat. Whoa, excuse me. And so my z is going to be negative 1.98. So I have to look at my rejection region. My rejection region, I have two of them, and that's because it's a two-tailed test. And so I have 5% in each end. And if I put that in my normal calculator, I would see that I would get 1.645 on this side and negative 1.645 on this side. So these are my rejection regions. If I'm less than negative 1.645, I'm going to reject. If I'm greater than 1.645, I'm going to reject. If I'm in the middle, I'm not going to reject. So let's grab our z-score. Our z-score is negative 1.98. Well, that's over here. And since it's sitting in my rejection region, that's my negative 1.98, that also shows me that I'm going to reject. I'm really just proving the same thing. And so let's see, I think that was my claim as well. So since I rejected the H naught, I cannot support my claim.